Okay, so that has to do with similarity transformation. So we are going to be graphing two figures today and finding the scale factor between those similar figures. So before that, I just want to go over some vocabulary having to do with this. So transformation is an operation that maps an original figure onto a new figure. Okay, so you're taking one figure, you're moving it to make a new one. The pre-image is the original figure. Okay, so it's the one that you start with. That's called your pre-image. Your image is the ending figure, or your new figure. So the one that you create. Okay. So we do have a similarity transformation. That is a transformation that produces similar figures. Okay, so when we're producing similar figures, we have something called a dilation then. Okay, so a dilation is a transformation that enlarges or reduces the original figure proportionally. So you're kind of just multiplying this dilation into the lengths that you already have. So the scale factor of a dilation we call K. Okay. So we use that variable K for the scale factor of that dilation. It is the ratio of a length on the image to its corresponding length on the pre-image. So it's still just the scale factor that we've been finding for all of our similar polygons and figures. Okay, so K is just that ratio between your two images. So the scale factor of your dilation, just kind of written out, is the length of the image. Okay, so in the numerator of your ratio, it's the length of the image over the corresponding length of the pre-image. Okay, so you're going to take your new image length, so your new one that you just found, it's over the original. Okay, so it does have to be in that specific order. Okay, so it'll tell you which one is the image and which one is the pre-image, so you're able to create that scale factor correctly. So using that scale factor, you can determine if your image is an enlargement or a reduction. So if it's an enlargement, the dilation with K is going to be greater than 1. Okay, so that means your fraction has to be greater than 1. So it could be 3 over 2. It could just be 4 over 1. Okay, so if it's greater than 1, it is called an enlargement. For it to be a reduction, the dilation, your K value or your scale factor has to be between 0 and 1. Okay, so K is between 0 and 1, meaning it's going to be a fraction. So like 1/2, 1/3, 1/4. Okay, so any of those between 0 and 1. It won't be negative. Okay, that's not what this is saying. It has to be that smaller fraction. Okay, 2 over 3. So just not a fraction greater than 1. So we are going to do a couple examples of this. So in numbers 1, 2, 3, and 4, we want to determine if the dilation from A to B is an enlargement or a reduction and state the scale factor. Okay, so that means your newer image is B. Sorry. And your original is A. Okay, Okay, so I'm just going to kind of highlight how I highlighted in my scale factor up at the top there. So our new one, again, is B. Our original is A. So we have B as the image, A is the pre-image. Okay, that's going to help us create this scale factor. So our scale factor is K. Again, that's equal to the image over the pre-image. And since our figures here lie on a horizontal, we can just count that distance on our graph. Okay, if it wasn't on a vertical line or a horizontal line, we couldn't count those and we'd have to use the distance formula. Okay, but since they are, for our image B, we just need to take one of the sides and its similar side in our pre-image A. And we just have to count the distance between points. So we have 1, 2, 3, 4. Okay, so that top line there in image B has a distance of 4. So for that image piece, we can write 4. Over its similar side in pre-image A, again, count your distance between points. That's 1, 2. Okay, so we have a distance of 2 along that side. Okay, and we can just reduce this to 2 over 1. Now with that scale factor K, we want to see if that is between 0 and 1 or if that's greater than 1. Okay, so it's 2 over 1. Is this going to be an enlargement or a reduction? It is an enlargement. And you should see that. So from A to B, it did get larger. Okay, it is an enlargement. So that's a good way to check if you made your scale factor correctly. Okay, we're going to look at number 2 then. And we want to do the same thing. So we're going from A to B. So that means B is your image. Okay, so B is your image. That's your new figure. And A is your pre-image. That's your original. And I always want to pick out the sides that are either horizontal or vertical along those lines, because then I can just count and I don't have to use the distance formula to find that side length. So our first step is to solve for our scale factor of K. So finding K, we need the new image, which is what I highlighted in yellow, so that's B. So I want to count that distance between points along that side. So I have 1, 2, 3. Over its similar side in figure A, which is the original or your pre-image. And again, count that length between your points. And I got 6. So I have 3 over 6 is my scale factor. And I do want to reduce that to 1/2. Okay, so now that I have a scale factor of 1/2, I want to say if this is an enlargement or a reduction. Okay, and since my scale factor is between 0 and 1, this is going to be a reduction. Okay, so again, it's always your image over your pre-image. So it's your ending figure's length, one of the side lengths, over the original's side length. Okay, with those similar sides. Questions on 1 and 2? All right, I want you to try 3 and 4. Again, look for the sides that are horizontal or vertical, so you can just count the distance between those points. Because if you're picking ones that are diagonally through, you're going to have to use the distance formula. And that makes it a little bit more challenging. You can't do it this way. You can do that along this side or along this side. It has to be vertical or horizontal for you to just count. You can pick this side or you can use this side. It doesn't matter. So B is your image. So count the points for B, and then over count the points for A. Yep. Colors are using. Alright, so most people are finishing up with these two problems here. So for number 3, again, B is your image, A is your pre-image. So I need K to be the length of one of the sides in B over that similar side in figure A. So for B, I'm going to choose this side right here, and then the similar side in figure A. Okay, so don't switch up sides. It has to be those similar sides, just like we've been dealing with throughout the chapter. Okay, since this one is a horizontal side, I can just count. So counting the points between, I have 1, 2, 3, 4, 5, 6. Okay, and then counting the points between in my pre-image A, I have 1, 2, 3. And I do want to reduce that ratio then to 2 over 1. So since my ratio is greater than 1, this would have to be an enlargement. Okay, and you can see that if you're going from figure A to figure B, it does get larger. Okay, so that's a good way to check. Number 4, same thing. I'm going to choose this top side here in both figures. So figure B, that length has to go over figure A, since B is my image. And again, I'm choosing that horizontal so I can just count. So my K, or scale factor, I would have 1, 2, 3 for B over 1, 2, 3, 4, 5, 6 for A. And then I just want to reduce that scale factor to 1 over 2. Okay, since my scale factor is between 0 and 1, that means this is a reduction. Okay, and you can see if you go from figure A to figure B, it does get smaller. Okay, questions on your scale factor or stating whether it's an enlargement or reduction? All right, then on the back, you can verify that a dilation produces a similar figure by comparing all corresponding sides and angles for triangles. So we can use side angle side similarity or side 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 similarity. Okay, so we're going to draw out our two figures. One is going to be our pre-image, the other is going to be our image. And we need to compare the angles and sides between the two to see if those are actually similar figures. So that is what we're going to do in the next example. So we're going to graph the original figure and its dilated image, then verify that the dilation is a similarity transformation. So we are given the pre-image coordinates, and I do want you to plot those. So point A is at -3, 4. Point B is at 2, 4. And C is at -3, -4. Okay, so that is my pre-image right there. Okay, then I want to plot the points for the image. Okay, so the image is at point D is 1, 0. Okay, point E is at 3.5, 0. And F is at 1, -4. Okay, so that is my image. So I either want to prove that these are similar by side, 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 or side, angle, side. Well, if I look at both of these triangles here, right, what do we know about angle A and angle D? They're 90 degrees, okay? So I know angle A is 90 and angle D is 90. Okay, so angle A will be congruent to angle D, since they're both 90 degrees. Okay, so I'm on my way to trying to prove these are similar by side, angle, side, because I have an angle that's congruent, right? So for it to be side, angle, side, that means I need to look at the sides that surround that angle. So I want to make a ratio. Now it doesn't have to be the scale factor. Okay, I am going to write it as the scale factor so you just get practice with it. But it could be just going from triangle ABC to DEF or vice versa. So we're going to make a ratio from side DE to AB. Okay, so I went from my image to my pre-image. So I want to find the length of DE over AB, since those would be my similar sides, correct? Well, the length of DE would be 12.5 over AB's length is 1, 2, 3, 4, 5. What do you know about 2.5 and 5? You can reduce it to 1/2. Okay, so 2.5 is half of 5. Okay, I want to do the same thing to the other side that surrounds that angle. So since I started with my image in this ratio, I'm going to start with my image in the second one. So I'm going to compare DF to AC. And again, since these ones are either horizontal or vertical, we can just count. In some cases, you can't. Okay, so there will be some cases where you will need to use the distance formula to find that length. And this one, you don't have to. So side DF is 1, 2, 3, 4. Over AC's length is 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can reduce my ratio then to 1/2. So now, since I have my angles congruent and my sides have the same ratio, I can say triangle ABC is similar to triangle DEF by side angle side similarity. Okay, so I need to write out, you can't just say this part without first showing this. Okay, so you need to write this out. You need to write out that those two angles are congruent. You need to reduce the sides to their ratios to make sure they're the same. And then you can say that they are similar. Okay, questions on example 1? All right, then I want you guys to do number 1. Don't do number 2. I'm going to do that one. You can plot the points for number 2 if you want, but I want you to do number 1. Okay, it's very similar to the one we just did. Okay, the top one here is your pre-image. Okay, and the bottom one is your image. Again, for writing out to prove these are similar, it doesn't matter that order, but I just wanted to let you know which one was which. Okay, so the top one's your pre-image, the bottom one is your image. So same process we just did in that first example. Try and prove that those two figures are similar to each other. I have a feeling you didn't do the last one right, if you're done already. Because we didn't go over that yet. No. Alright, so for this first one, I have my two figures drawn in. So with these, again, I have this 90-degree angle. So I have angle F is congruent to angle C. Okay, so that's the first part I needed there. So I want to check the sides that surround those two angles to try and prove this by side angle side. So I'm going to compare side EF to BC. And I want to compare side DF to side AC. What? If it's flip-flop? No, your ratio will just be flipped compared to mine. So here side EF has a length of 5 and BC has a length of 8. Okay, I can't reduce that, so I'm just going to leave it as is. And then with side DF, I have a length of 3 over AC has a length of 6, which I can reduce to 1 over 2. So I need to compare my ratios. So this one and this one. Okay, so those two ratios are not the same, right? So this would not be a similarity transformation. Okay, so we do need that those ratios are the same in order to prove that those two triangles are similar. Since they are not, it is not a similarity transformation. All right, then number 2, again, I'm going to plot these points here. So P is at -4, 1. Q, -2, 4. And if you haven't plotted these yet, make sure you do. R is at 0, 1. Okay, so that's my pre-image. Then my image I have at 1, -1.5. That's W. X is at 2, 0. And Y is at 3, -1.5. All right. So as of right now, can I prove that any of my angles are congruent to each other? No. So that means I'm going to have to try and prove this by side, side, side similarity. So I need the distance of all 3 sides. Okay? The ones that are the easiest to find, again, are the ones along the horizontal and vertical. So if they're horizontal or vertical, you can count. However, I have 2 pairs of sides here that are not. Since they are not, you need to use the distance formula. That's the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And yes, you have to use this on your assignment. There's one on the front page that you have to use it on. Okay? And there's one on the back page that you have to use it on. So, since I need to find the distance of all the sides, I labeled out all the sides for you below. Okay, so we're going to find the distance of each side. So the first ones, I have WY, WX, and XY. So that's from your image. So WY is the easy side to find because it's a horizontal line. Okay, so that distance is 2. Okay, you just have to count. 1, 2. So my distance for WY is 2. For WX, I need to use the distance formula, and I'm going to use points W and X above here. Okay, so I need to take X sub 2, so that would be 2, minus X sub 1 is 1, that quantity squared, plus Y sub 2 is 0, minus Y sub 1 is negative 1.5, and that quantity is squared. Okay, so from here, I'm just going to simplify. So I have 2 minus 1. That's 1, right? 1 squared is 1. Okay, plus I have 1.5 squared. That is 2.25. Okay, so I end up with the square root of 3.25 for Wx. Okay, we need to do the same thing with xy. So we have the square root, and this time I'm taking points x and point y from above. Again, just plugging it into your distance formula here. So I have x sub 2 is 3, minus x sub 1 is 2, squared, plus y sub 2 is negative 1.5, minus y sub 1 is 0. That quantity squared. So again, just simplifying, I have 3 minus 2, that is 1. 1 squared is 1. And negative 1.5 squared, that is 2.25. Add those together, I get 3.25. The square root of 3.25. I'm just going to leave them like that. So that was my image. Next, I want my pre-image. So I have side PR. That's the one along the horizontal here, so I can count. So it is 4. Okay. Then PQ, using our distance formula, using the points from above in your problem. So I need x sub 2 is negative 2, minus x sub 1 is negative 4, that quantity squared, plus y sub 2 is 4, minus y sub 1 is 1, that quantity squared. Okay, we're just going to simplify. So I have negative 2 minus negative 4. Okay, so that'll be 2. 2 squared is 4. 4 minus 1 is 3. 3 squared is 9. So square root of 13. And again, I'm just going to leave it like that. Same thing with QR. Sorry. Using points Q and points R in your distance formula. We have x sub 2 is 0, minus x sub 1 is negative 2, quantity squared, plus y sub 2 is 1, minus y sub 1 is 4, that quantity squared. So I have 2 squared in that first quantity, that's 4, plus 1 minus 4 is negative 3, negative 3 squared is 9. So I do end up with the square root of 13. So now I need to set up my ratios of all 3 sides. Okay, so that would be WY over what? Which side is similar to WY? PR. Okay, so WY is 2 over PR is 4. That's 1/2. Okay, next I have WX. WX is similar to which side? PQ. Okay, so Wx I found to be the square root of 3.25 over the square root of 13. What I want you to do on your calculator, okay, I want you to take the square root of 3.25, okay, press equals, divide it by the square root of 13. You get 0.5. What's 0.5 as a fraction? 1/2. Okay. The last one I have then is side xy over QR. Again, that's the square root of 3.25 over the square root of 13. And again, we found that to be 1/2. So all three of our sides have the same ratio. So we can say that triangle PQR is similar to triangle WXY by side, side, side similarity. Okay, questions on how I did that last